for this part of the lesson, we're going to be really focusing in on the P and the equation. So far I've just told you that the equation of the parabola in standard form is y squared is equal to 4px, or x squared is equal to 4py. We really haven't talked about what this p is. So let's go ahead and look at this one. We're going to label the vertex. And so that is here at 0, 0. And the distance is 1. And that distance of p is the distance from to the focus. And so that distance on this graph is right here. That's P. Label the focus with its coordinates. And so the focus is at the ordered pair of P, 0. It's a 0. And then we're going to label the directrix of the equation of the line. That's going to be x equals negative, whatever that distance is, p. So x equals negative p. And what is the distance from the focus to the directrix? So this distance here is 2p. So now let's go ahead and talk about the equation of the parabola. And so we're going to use, we want D1 to represent the distance from the point Q on the parabola, so that's just going to be xy, to the focus. And remember, the focus was P0. And so that distance 1 is equal to the square root of x minus p squared plus y minus 0 squared. And so we end up with the square root of x minus p squared plus y squared. And so that D1 is a square root of x minus p squared plus y squared. And now we're going to find D2. And so this time, that point D2, where we're going from, represents a perpendicular distance from point Q. So that point Q, remember, was x, y, to R, which is going to be a point perpendicular. So this point right here. So let's see, that was where the Q was. And so this point is going to be at the same height. So we know we have that same height of y, but we are back a negative p distance. So it is negative p, comma, y. And so let's find that distance 2. Similar to how we found the distance 1, we're going to do with these 2 points. And so we have the square root of x minus a negative p squared. Those 2 become a plus y minus y squared. And so we have the square root of x plus p squared plus 0. Well, that doesn't have to be written. So our distance 2 is a square root of x plus p squared. And so oops, I ended up writing it in the wrong spot. this is this distance formula. Let's see if I can get it moved. Oh. Goes down here. Now, we want to write the equation using that part that we just came up with. And so we know that those two distances have to be equal. So the square root of x minus p squared plus y squared has to equal the square root of x plus p, that quantity squared. And so we're going to go ahead and multiply that out, and I'm going to come down here to show my work. X minus p times x minus p. So we end up with an x squared and negative xp, negative xp, and a p squared. And so when we combine that, you have that x squared. This becomes a negative 2xp plus p squared plus y. Now let's do the same thing, but this time we're going to have a positive in both those places. The only thing that's really going to change is that. So we have the square root of x squared plus 2xp plus p squared. Now to be able to solve this, we can get rid of the square root on both sides by squaring it. And so we have x squared minus 2xp plus p squared plus y is equal to x squared plus 2xp, oh, that's a y squared, excuse me. That would cause us problems later, plus p squared. And it wants us to get so that one side of the equation is a squared term. Well, if I look here, what looks like it may be my squared term that's left is going to be this y squared, because these two will cancel out when I move things around. So I'm going to go ahead and move things over to where all my x's and p's are on the same side. And so those will cancel, those cancel. Since I moved that around, those will all cancel. And so we end up with y squared is equal to 4xp. And so we just created the formula that is our standard form equation. And that just shows that distance is the p. That just proves that is that distance, as we came up with the standard equation. And so we're now going to go through, and we're actually going to be working with multiple versions of this and finding out where the vertex is. We're going to graph it. We're going to determine the coordinates of the focus and the directrix. So let's go ahead and take this first equation. We have y squared is equal to 20x. So that immediately tells me that my parabola is going to be opening, is a horizontal parabola. That means my axis of symmetry is going to be y equals a number, in which, since we haven't gone off the origin yet, that's going to be y equals 0. And so that gives me my axis of symmetry. And then my coordinates of my vertex is 0, 0. Now we want to figure out what the value of p is. Well, we know 20 has to equal 4p. So therefore, p is equal to 5. So that means that our focus needs to be to the right of that origin, because we need to go positive p, 2, 3, 4, 5. That's where our focus is. That focus is at 5, 0. Our directrix is going to be 5 backwards. And so we're going to have that directrix back here. At x equals 5. Oops, I just did that backwards. So, no, that was right. I just blinked out there for a second. And so we know our parabola is going to be opening this direction. The concavity of that parabola is concave right. Because this is a positive 20, that means we needed to go right a positive 5. And so here's a better graph of that same information than my little sketch. We're going to do the same thing, but oops, I think I may have skipped. Pause this real quick. So on equation 2, we have x squared is equal to negative 12y. So we want to find the vertex of it. So far we've had the vertex always at the origin. And since this is x squared, that means my axis of symmetry is x equals 0. Now we're going to find p. And remember, p is that neighbor in front, so equal to 4p. And so we divide both sides by 4. So we have a negative 3 is equal to p. And so our vertex was at the origin. Our axis of symmetry is x equals 0. And this is what means that we're going to have a vertical graph. And my p is at negative 3. So I go down 3. And that's where my focus is. So my focus is this time at 0, negative 3. And my directrix goes back that opposite direction, p units. So it's going to be y equals positive 3, because an opposite of negative 3 is positive 3. And then I go from my vertex, and I'm going to curve towards the other. And so your graph should look something like this. Let's do another one. So we have the parabola representing the equation x squared equals 28y. So we want to find the vertex of the equation and the line of symmetry. So again, vertex 0, 0. Line of symmetry, it's x squared, so it's x equals 0. To find that value of p, we plug that equal to 4p. And so 7 is equal to p. And so we're going to go ahead and graph this. And because it's x squared, that means we have a vertical graph. And it was 7, so 1, 2, 3, 4, 5, 6, 7. That's where my focus is, 0, 7. My directrix goes down 7 units. And we are concave up because our P is positive. And so this is what your graph should have looked like. The scale is a little bit different than I used on my sketch, but this is the equivalent of it. So if we're considering the equation for the parabola is y squared equals negative 10x, that means my axis of symmetry is y equals 0, and my vertex is 0, 0. And so to find that value of P, I'm going to take that negative 10 and set it equal to 4P. And so I'm going to divide both sides by 4. So that gives me a negative 2.5 is equal to P. And so when we're sketching this, you would have gone back from the origin negative 2.5, and our directrix would go 2.5 the other way, and you would sketch it opening to the left, so it's concave left. I don't think I actually listed those. Yeah. Focus is at negative 2.5, comma 0, and my directrix is x equals positive 2.5. So when we're looking at the relationship between the sine of P and the concavity for each parabola, and so if P was negative and it was an x squared, that means it opened down, or it's concave down. If P was positive and it was with x squared, it would open up. If P was negative and it was y squared, that means we're going to be opening positively for the horizontal, so that means concave right. Oh, that was negative. Sorry. I did negative first. Goes to the left. If P was positive and we were y squared, that means you open right. And so let's look at the equation. So here it is going to be x squared is equal to 4py. It's a vertical orientation. It's a y-axis, or x equals 0. Coordinates of vertex is 0, 0. Coordinates of focus is 0p. Directrix is y equals opposite of that. And it's, if P is greater than 0, it's concave up. If P is less than 0, it's concave down. If P is equal to 0, that means we don't have a quadratic. So the next one is y squared is equal to 4px. This is horizontal. It's got the x-axis, or y equals 0. Still got the ordered pair as the origin. This time it's going to be p comma 0, and x equals negative p. If p is greater than 0, it's concave right. If P is less than 0, concave left. we're going to be looking at the distance formula to determine the points or equidistance. So we're going to be looking at writing the equation if we're given the focus and directrix. So we're told those two things, and we're going to try to come up with the equation. And so this time, we are not going to be having our graph at the origin. And so we need to figure out where would those points be. So we're going to start off the same way we did before. We know that we're going to be equidistant from the point 3, 5, that's our focus, and the line y equals 3. So that means that we need to come up with the two distance formulas. So we need to find distance 1 and distance 2. And so when we start this, we have to find the order pairs. And remember that one of the order pairs is going to be x, y each time. So let's start off with the distance 1. So x minus a negative 3 squared plus y minus a negative 5 squared is equal to distance 1. Distance 2 is going to have that xy down here, but we know for certain that our y is going to be 3. So that's going to give us the order pair for that spot of x comma 3. And so those are our two order pairs. And so we have x minus x squared plus y minus 3 squared is equal to our distance 2. And so we have the y minus 3 squared. I'm going to square root that. And so now let's go ahead and set those two equal to each other. Oops. Okay. And so when we do this, we're going to square both sides, which cancels out that square root, and that gives us x plus 3 squared. And then we have that y plus 5 squared is equal to y minus 3 squared. So the next thing is we need to kind of multiply everything out. So when we multiply that y plus 3 squared, or excuse me, x plus 3, end up with x squared, 3x, 3x, and 9. Oh, it's not 3x, 6x. And then we're going to do the same thing on the other side, or excuse me, with the y's. Y plus 5, y plus 5, that gives us y squared, 5y, 5y, and 25. So that gives us plus y squared plus 10y plus 25 is equal to, and now we're going to do our y minus 3. And so we have y minus 3 y squared, negative 3y, negative 3y, 9. 6y plus 9. And then I'm going to take and move everything to the same side. I'm going to subtract the y squared, and make sure you subtract it from where it goes. I'm going to add the 6y. I am going to subtract the 9. In which it'll make it easier to subtract it from there. And so we have x squared plus 6x. Those cancel, those cancel. This becomes a 16y plus 25 is equal to 0. And so our equation for that line is x squared plus 6x plus 16y plus 25 is equal to 0. And so if we want to try to figure out where our coordinates of our vertex is, we need to figure out how far from that focus we need to go. And so when we're trying to find that, that means we need to take and look and see, okay, this distance here is P. And so how far, 1, 2, 3, 4, is how far away we are. In which you can really find the vertex just by looking at the graph. Let's say it wasn't graphed. Well, you take and go 3 up on your y, and that would be your vertex. Your vertex is at negative 3, comma. Actually, 4 up, excuse me, negative 1. And then our axis of symmetry is going to be x equals the x value of that vertex, so negative 3. So let's look at this next one. We have the equation, all the points equidistant from 7, 5 in the line 1. And so we're going to find it the same way. And so we have x minus 7 squared plus y minus 5 squared is equal to our distance 1. Our distance 2 is we need to get an ordered pair over here. And so that ordered pair is going to be that same y height, but 1 comma that y. And so we're going to use these next 2 points for our next distance. So x minus 1 squared plus y minus y squared. Is that distance 2 is x minus 1 squared is equal to distance 2. And so to find that equation, we're going to end up setting those two equal to each other. And you can get rid of the square root at this point, or like I did last time, where you get rid of it later. So let's go ahead and get rid of it now. Square both sides. So x minus 7 squared plus y minus 5 squared is equal to x minus 1, that quantity squared. And so we're going to use those boxes to help us multiply. X minus 7, x minus 7, x squared, negative 7x, negative 7x, positive 49. And so that gives us x squared minus 14x plus 49. And then we're going to do the same thing with the next one. We have y minus 5, y minus 5. And so you have y squared, negative 5y, negative 5y, positive 25. And so we have plus y squared minus 10y plus 25 is equal to, and now we got to multiply the other side. And so we have x minus 1, x minus 1, x squared, negative 1x, negative 1x, 1. And so we have x squared minus 2x plus 1. Now move everything over to the same side. Subtract x squared, add 2x minus 1 minus x squared plus 2x minus 1. Those all cancel. And we end up with a negative 12x, a positive 48, plus y squared minus 10x plus 25 is equal to 0. Or 10y, excuse me, not 10x. And so now we're going to combine like terms and get things rearranged. And we are going to rewrite it. So we have y squared minus 10y minus 12x, and then 48 plus 25. This will give us 3, carry the 1, 73 is equal to 0. And so that is your equation in the general form. So if we look at the coordinates of the vertex is halfway between these two. So that means that our y value is going to stay the same. But our x value is halfway between 1 and 7. And so we're 3 units away from each of those. That means it's going to be at 4. You can see that off the graph. Or you could have found the difference of those, and that was 6 divided by 2. And that gives you how far you need to move away from your vertex. And then our axis of symmetry is equal to y equals to the y value of your vertex. If we were to rewrite those two into one of these two forms, we want to have it in one of these two formats. So equation 1 is going to give us the first one. And so we're going to take from question 1, we had x squared plus 6x plus 16y plus 25 is equal to 0. So to get it in this format, I need to take and get my x's on one side and everything else on the other. So I'm going to subtract the 16y minus the 25, minus 16y minus 25. And so I end up with negative 16y minus 25 over here. And then I need to take and complete the square. So remember when we were talking about completing the square earlier? You take that 6, divide it by 2, and you're squaring it, and that's what's going to be added to both sides. So that's 3. 3 squared is 9, so we're going to add 9 to both sides. Now we're going to combine like terms. Negative 16. Negative 25 plus 9 is going to be negative 16. So I'm going to factor that out over here on the right-hand side. Negative 16 is equal to times y plus 1. So we kind of have it in that format right here. Now we got to factor this. And when we're doing completing the square, remember this number inside went at the end. This middle sign drops down, and the x. And so that is that format. And so now we're going to look at question 2. Question 2, we end up with the equation of minus 12x minus 10y plus 73 equals 0. So now we're going to get it grouped together. So the y squared minus 10y, and I will move these others to the other side. Positive 12x minus 73. And so I'm going to take that negative 10, divide it by 2, and square it. So that's going to be negative 5 squared, which is 25. That's what I'm adding to both sides. And so that gives us y squared minus 10y plus 25 is equal to, we have negative 73 plus 25 equals 48, or negative 48. Now I need to factor out that negative 12, or positive 12. I don't know where that negative came from. And so 12, and then we have y minus 4. Over on the other side, when I factor it, remember we have the y, this middle sign, and then that number. So that's your equation. So I want you to try to do numbers 4, A, and B. And that's going to be your homework. I will check those at the beginning class tomorrow. I just want you to get it to where it's factored and set up to where we can go to this. You don't have to do the sketching. I just want you to get it into standard form.